So last year, when we were last together, we went over this summary of adding, subtracting, multiplying, and dividing positive and negative numbers. Did you guys all get this purple sheet when we were last together? Okay, so you might want to have that out as you are doing these problems to get until you don't need it anymore, right? These things, to keep them straight, especially the difference between addition rules and multiplication division rules, you have to practice them a lot, and we are going to practice them a lot. Today, Thursday, Monday, practice, 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 and then next Thursday will be the unit test. Okay, so the last thing we have to do is today's lesson, which is to just add them all together, put multiple operations together. And so you need to know how to do each individual type of operation. That's this notes page. And you also need to know how to do multiple operations in the same problem. And that is this notes page, which we went over at the beginning of this unit. Okay, the order of operations, which things you do first and which things you do second. We did this quickly at the beginning of the unit with all positive numbers, which was review from last year. And now this year, we're going to do these operations all mixed together with negative numbers. Parentheses or grouping symbols first, then exponents, then multiplication and division at the same time, left to right, then addition and subtraction at the same time from left to right. A different way of kind of going through that order of operations is sort of a strategy for people who have a little trouble with these things, is you're kind of going through the whole problem with like a little filter. Okay, so the first time you go through the problem and you look for anything that's happening inside parentheses or grouping symbols. And you do those operations. If there's more than one set, you do them from the innermost set and then complete them as you're going out. Okay, until you don't have any more parentheses with operations in them. Then you go through, you start over again, and you look for any operations with exponents. This little button here, this little symbol, the caret symbol, is what you can use to show an exponent when you can't do a superscript on your whatever you're typing in digitally. Yes, Roman? What?
What's a superscript?
Superscript is when you type a number when you're typing and you make a little number above the line of the regular text. This 2 is a superscript 2. It's above the regular line of text. You can also do subscript, which is below, which we'll see later on this year, okay? But sometimes you're in class kick, you're typing in class kick, you don't have a superscript button that you can do this with, okay? So the way to write 3 to the second when you can't do this little raised little number is to use the caret key, okay? So this 3 caret 2 is the same thing as 3 to the second. Okay, this caret is a shift 6 on your keyboard.
How can you do that on a calculator?
You don't need to do it on a calculator. On a some calculators have the caret button on them too.
Well, I didn't have the caret button, but I just had the caret button on the keyboard. Apparently, it accepted it.
Yeah, I mean, a calculator will either have the caret button to do this, or they'll have a Y to the X button, and then you type in the 2 numbers. But you're not using a calculator for anything in this unit, so that doesn't matter. Okay. My point is that if you have to type an exponent and you can't do superscript, use a caret key. Okay. This 3 caret 2 means 3 to the second, which means 3 times 3, right? An exponent is repeated multiplication. Once you get rid of all the exponents in your problem, then you can go back and start over and do all the multiplications and divisions from left to right, and then you can do all the additions and subtractions from left to right. And the preferred method for writing this work is to, underneath each line, write what you get after you do that operation. Okay, so you do the parentheses, and underneath you write your answer to what came out in the parentheses. And everything else you just carry down and you write the rest of the problem. So when they get long, you have multiple steps here. And I know you did this last year with all positive numbers. This year, we're going to do it with some negative numbers, okay? So I'm going to do these 4 examples first to show you how the work should look for these and to go over how to do them. So 3 minus 8 times 2. Remember, we're not using x's for multiplication signs anymore. A number next to parentheses is multiplication. Parentheses next to parentheses is multiplication. Number next to letter is multiplication, right? No x's. So I'm not going to, the first thing I'm going to do here is, well, there are no parentheses in this problem. Now you say, Mr. Riley, there's parentheses in that problem. Okay, well, yeah, there's parentheses around this too, but there's no operation inside these parentheses to do. There's no operation inside the parentheses. These parentheses are just there to keep things separated. Okay, they're not really grouping to have you do any operation first because there's no operation in there. Okay, so there really are no parentheses in this problem, no grouping symbols. Okay, there's no exponents. So I go to multiplication division. This I have to do first. So 8 times 2. So 8 times 2 is 16. And some people, and I've seen people do this because when you learn order of operations, a lot of people will do this, right, to kind of show what operation you did and what your answer was for that operation. It's a good strategy. I don't require you to do it, but it's kind of helpful to do to keep things straight, especially when things get more complicated. Okay. Now I'm going to do 3 minus 16. I don't do subtractions. I change them to plus the opposite, same change, change. Okay. You could write same change, change as another line like this, 3 plus negative 16. Or you could do this. Right, you could do that for same change, change on the same line and not write this here. And then write your answer, which is negative 13. When you add numbers with different signs, you subtract the values, and your sign of your answer is whichever the sign is of the larger value, right? So negative 13. 2 times 3 minus 5 to the second. Again, no grouping symbols here. There's parentheses, but they're not grouping symbols. No operation in between. So I start with exponents. 5 to the second. What's 5 to the second, Matthew? 25, because it means 5 times 5. So first I'm going to evaluate the 5 to the second, the exponent. Okay. And then multiplication and division left to right. 2 times 3 is 6. Okay, you could, if you wanted to, write this. Man, I wish I could figure out how these pens work. Right? 6, and then 6 minus 25, that's another subtraction. That's not a second grade subtraction. So same change, change again. You could write like that if you wanted. Or you could rewrite like that, and your answer then, negative 19. Okay. Some people will even put this here like this. Right? That's optional, writing those little funnel things. All right, next one. Hey, there's parentheses in this one, so I got to do what's in the parentheses first. That's a second grade subtraction, so I don't have to change anything for that. I can just do 5 minus 1. Which is 4. Okay, so just do the parentheses first, and you carry the rest of the problem to that line. No exponents. Multiplications, divisions. 2 times 4 is a multiplication. That's 8. Third grade multiplication. Again, you could do this if you wanted to. And then negative 3 plus 8 is positive 5. So if you wanted to, you can do that. Last example here, I got, this is a division. Oh, it's a fraction, Mr. Riley. Yeah, it's a fraction, but fractions are how we show divisions now. Okay, Now, you'll see elementary school division symbols in some of the practice problems that we do, but typically, if I make a problem up, I will not use an elementary school division symbol. This is how I write divisions and how you will write them for the rest of your math career in general, okay? So this means negative 27 divided by 3. There's an addition here, and this negative 5 plus 3 in parentheses underneath here, these parentheses don't really have to be here because this fraction bar is actually grouping symbols by itself, okay? But this sort of makes sure that you know that you're going to do this addition in the bottom of this division. You're going to do the addition first before you do any division here. So that's the first step, and I will tell you that when you have things that are separated by additions or subtractions, you can kind of do them all at the same time. So some people would write on the next line, negative 27 divided by 3 plus 16 over negative 2. But other people, and you're welcome to do this, can do this division because it's separated by this addition. So I know that it kind of stands by itself, that I can do that division, negative 9, and here I'm doing what's in the parentheses, negative 2. Then I'll do this division, 16 divided by negative 2. That's negative 8. Negative 9 plus negative 8. Don't get confused. Negative plus negative is a big bunch of negatives because you're adding them. It's not positive. That's for multiplication and division. Negative 17. Okay? Only in multiplication and division. In addition, wrongs plus a bunch more wrongs makes a lot of wrongs. Right? When you're adding them together, I got bad guys and I got more bad guys, and I add them together, I get a big bunch of bad guys. There's no canceling of bad guys there. As opposed to bad guys times bad things, that makes a good thing. Right? That's for multiplication and division. That's one of the most common mistakes that people make with these, which is why we have to practice them mixed up so that you get used to not messing them up. Right, Maggie? All right. Here are 6 problems for you to do on your own. Number 1 here, 48 divided by 8 times negative 3. What's the answer for that one? Kenny?
Negative 18.
Negative 18, he says. I like it. 6 times negative 3, do the division first and then the multiplication. Oh, you messed that one up?
I didn't know to divide the 48 by the negative 3 or the 8, because there are 2 numbers there that could be divided.
Right, so this, when you do the order of operations and there are no parentheses, right? You go from left to right and you do each operation as you get to it. So from left to right, it's 48 divided by 8. That's 6. And then now you do the rest, okay? This one has parentheses in it, so it forces you to do them in a different order because you have to do what's in the parentheses first. So this one comes out to an answer of what, Roman? Okay, so it's a division. It's not a fraction. It is a fraction, but it's a division problem. Right? So it's negative 48 divided by negative 24. You can write it as a fraction if you want, but your answer shouldn't be over 1. Because over 1 doesn't mean anything. Right? 28 over 2 over 1 is the same as 2. Negative divided by negative, your answer should be positive 2. Negative divided by negative. If you left it as a fraction, negative 2 over negative 1, that's an unsimplified fraction. You got it, Marcus?
Yeah, that's not negative 48 by negative 24.
Negative divided by negative is positive. All right, number 3, negative 2 plus 8 squared, or plus 8 to the second. Riley, did you get that one?
Which one?
Remember this one?
62.
62 is correct. Exponent first, 8 to the second is 64. And negative 2 plus 64, subtract the values, take the sign of the larger number, positive 62. This one, you have to do the parentheses first before the exponent. You get for this one there, Kenny?
I think the answer is 36.
And you think correctly, Kenny, because it's positive 6, negative 2 plus 8 in the parentheses is positive 6. 6 times 6 is 36. All right, a little tricky now. Pete, somebody at home, what's your answer for this bottom one here? Negative 5 plus 2 to the third.
3.
3. You like 3? Anyone? Marcus likes it? I like it too. Because this is, first you do the exponent, 2 to the third. 2 to the third is 8. It is not 6. It's a very common mistake for people to write 6 when they do 2 to the third. Remember that 2 to the third means 2 times 2 times 2. It's 8. Okay? So negative 5 plus 8 then is positive 3. Who answered that at home? You guys
That
know
was
who? Who?
Emma.
Hi. Who was it that answered that?
It was me.
It's me. I'm not looking at the meat. I can't tell anything.
It was Emma.
Emma. It was Emma? Oh, excellent. All right. Last one here. Negative 5 plus 2 in parentheses to the third. What is the answer to this one, Marcus?
I thought negative.
Negative 9. I think we're going to find the same problem we had over here where people think this is 6. Close. Kenny.
I think negative 27.
I think negative 27. Okay, why is it negative 27 and not negative 9, Marcus? Okay, because you got this, negative 3 to the third, right? What does negative 3 to the third, what does that mean? Right?
Yeah.
This means negative 3 times negative 3 times negative 3, which is not 9, but 27. Negative 27. Good job, Kenny. Okay? We're going to talk about this negative number with an exponent here in the next problems, next set of problems. Yeah, well, yeah, I wouldn't go now. I mean, if you can hold out for like 10 minutes, then when I finish these problems, then it will be, you'll be free for the rest of class. Okay? All right. Moving on to evaluating algebraic expressions. Now, the only difference between these problems and the ones that we just did are that these start with variables in them and give you values that you have to substitute in. All right? You must, in these problems, you must show the substitution step. Okay? You must show the substitution step. If this was a test or quiz question, and it says in the instructions, show the substitution step, and you don't show it, you are going to lose points. The substitution step doesn't do any operations at all. You don't change the problem at all. You just substitute in the values that you are given in for the variables in the problem, okay? Letters right next to each other mean multiplication. It is a good practice when you substitute in numbers in these problems to put them in parentheses to hold the numbers together. You don't want to use X's for multiplication anymore, okay? So when I do the substitution for this first problem, it's negative 2 times 3, and I'll write it like that. I could write just one of these numbers in parentheses and the other number not in parentheses. That would be okay, right? You could do it that way. So it could look like this. You could write negative 2 times 3 like that, or you could write negative 2 times 3 like that, or you could do it with a dot. Okay, or a star, do not use an X. Okay? So that's -6. Once you do the substitution step, then use your order of operations. There's no order of operations in that one because there's only one thing to do. This one, 7 minus BC. BC is B times C. So it's 3 times -5. I did not change this subtraction. I didn't make it plus the opposite or anything like that. No other changes. Just substitute. Now do the order of operations. There are no parenthesis grouping symbols in this problem. There are no exponents. So it's multiply and divide from left to right. And here's a multiplication. So I'm going to do 3 times -5 and get -15. Positive times negative is negative. Good thing happens to a bad person, that's bad. Now I can do this in subtraction. I could rewrite it because I don't do subtractions. I change them to addition. 7 plus +15. You could do this if you wanted, or you can rewrite it, and then your answer is +22. Fraction bar for division. Substitute, don't do any other changes. This minus sign in front of the variable means the opposite of whatever that variable value is. If this b was negative, which it is not in this problem, but if it was negative, then this would mean the opposite of b, which would make it positive. Okay, that negative sign in front of a letter means the opposite of. Does not necessarily mean the number is going to be negative. Opposite of. Okay, so in this problem, it doesn't matter because b is positive. So it's -2 for A, the opposite of B, -3, and then minus C, which is -5. So I need that in parentheses, otherwise it looks weird. Okay, no parentheses grouping symbols, no exponents. The fraction bar actually is like parentheses. The fraction bar is a grouping symbol. So I'm going to do what's underneath the fraction bar before I do the division. So that's 3 plus 5 underneath. -3 plus 5. -3 plus 5 is 2. -2 divided by 2 equals -1. All right, go ahead and do 4 and 5 on your own. Yes, Roman.
I don't know where I went wrong with number 2.
Number 2.
I got -20.
7 minus 3 times -5. You did the subtraction before the multiplication, which is bad order of operations.
Oh, this is what we're saying.
You have to do multiplications and divisions first, and then additions and subtractions. And so the multiplication and division, you do them together left to right, but you don't do any additions or subtractions before the multiplications and divisions are done.
No.
Okay? Excellent. Excellent. Nice, nice. Okay. All right, so I've seen some good work on the first one here. Substitute. Do not do anything else, just substitute. Again, one or both of these could be in parentheses. It doesn't really matter. You can use a dot. Order of operations, so no grouping symbols, no exponents, multiplication, division. Here's a multiplication. So that's negative 12. And then negative 3 plus negative 12 is negative 15. I think most people had that one right. This one is tricky. If you wrote this as your substitution, and then you went to do this problem and you say, okay, well, there's no parentheses, there's an exponent, and the exponent is 3 to the second. This minus sign in front of this 3 is really multiplication. It's really negative 1 times 3. Okay, this is weird, right? If you wrote it like this, your answer is negative 9. Okay, that is not what j to the second equals, because j is negative 3, and negative 3 to the second should be written like this. With parentheses. This is not allowed. Okay, this is incorrect for a substitution problem. If there are no parentheses there, the exponent only works on this number and not on the minus sign. So when you substitute for a variable, you have to use parentheses. This, negative 3 in parentheses to the second, this means negative 3 times negative 3, which is positive 9. And that is the correct answer for this problem. Now, I will tell you that this is a more advanced concept. You will see it again next year. Okay. There will be one question that has one of these exponents on the test. Okay. So practicing this and getting used to what to do with these negative numbers and exponents is sort of an advanced topic. Okay. There is an optional IXL assignment that I will post. You don't have to do it, but if you blaze through all the other ones and you want to try that one, you can. All right. So that's all I have.